Anyway, we will continue explanations first in the third section here, ionic compound and ionic bond. The table of content here, as you see that, we will talk about the ionic compound, how it's formed, how the ionic bond actually form. Then we talk about the formation of the ionic compound, how the cation attracted to the anion and form an ionic compound. A comparison of the ionic and the molecular compound, how the type of the bond affects the properties of the matter. So there is a huge difference in their physical properties, like in their melting point, the force of attractions will affect the properties, the ways they react, okay? And finally, we talk about polyatomic ion. So in today's sessions, we will just focus upon the first three main ideas, and then we could go. So first, we will compare the chemical formula for the molecular compound with one of an ionic compound. We will discuss the arrangement of the ions in the crystals. We will define what is the lattice energy and explain its insignificance. List and compare the distinctive properties of the ionic and the molecular compound. And finally, we will write the laws structures for the ionic compound. So, what is the ionic compound? Most of the rocks and the mineral that makes up the Earth's crust consist of the positive and negative ions held together by ionic bond. In the first sections, we just give you an intro about what is the ionic bond and what is the covalent bond. And we differentiate according to the type of atom. In the first, the covalent bond is bonded between what two types of atom? This is ionic or covalent? Non-metal for the covalent. What about the ionic? Hazim? Metal with non-metals. One of them comes from sharing their electron, and the others comes from transferring their electrons. Our topic today about the ionic compound. So we will focus about transferring of the electron. Okay, so example, the table salt, sodium chloride, consists of sodium and chlorine ions combined in 1:1 ratio in a positive Cl negative, so that each positive charge is balanced by the negative charge. Let's talk about this in detail. Ionic compound. This is section what?
Section 3.
Chapter 6. Okay. The first example is the table salt, right? What is the chemical name for it? NaCl. This is a symbol. What is the chemical name? Sodium chloride. Sodium chloride. Okay? Now, let's see what happened here. If we represent this with an equation, you will find that a sodium is a metal, right? So what does it mean of this? If you remember the electronic configuration of the sodium atom, what is the atomic number for sodium if you look to the periodic table? It's 11. This is mean if we make the electronic configuration for the sodium, the first main energy level, how many electrons inside it? 2. And the second one, 8 electron. And the third one, 1, 2, 3, 4, 5, 6, 7, 8. And the last one have 1 electron. So the sodium atoms, we know that there is an important role here. In the main energy level, how many electrons in the outer energy level? 1 electron. All the atoms wanted to reach what?
8.
Well, we named this octet rule. Wanted to reach here. So what is the easiest for sodium here? To gain 7 electrons or just to lose 1 electron? So these atoms here will lose 1 electron, but where this electrons goes? So as we represent, so the sodium will lose 1 electron and convert it to Na positive plus 1 electron, right? So why we represent here a positive charge? Because the number of protons is bigger than the number of electrons. Because the atom, when it's neutral, it have 11 electron, 11 proton. After it's lose 1 of this electron, so we have 10 negative charge versus 11 proton that 11 positive charge. That's why we represent the number of lost electron by the charge that loses here. So if he loses 2 electron, becomes positive 2. But in that case, here for the sodium, he only could lose 1. If we look to the chlorine atom, have how many? The atomic number is 17. So the first main energy level have 2 electrons, and the second one 8. The third one 7. It's represented by a dot that you could distinguish it. So here we have 2 electrons. Here we have 8 electrons, right? Now here how many electrons we have? This is 6 dots, and here is the 7th dot. So this electron here, when this jump from here to here, right? So this one, how many electrons he wanted to reach the octetrol? He need 1 electron to reach the 8. So it's easiest to gain. And the non-metals actually want to gain the electrons. So the Cl guys were represented Cl plus electron to convert it to Cl negative. And the negative represents that the number of electrons is bigger than the number of protons. That's why we represent. The positive ion here, we name it cation. And the negative ion here, we name it anion. So the total reaction, how the chemical, and this is the question here, how the chemical bond form or how the ionic bond form. The total reactions here, these electrons will cancel the other electron, and this charge will be neutralized each other, forming sodium atom plus chlorine atom to form NaCl, solid ionic compound, sodium chloride ionic compound. This bond form according to what? We name that electrostatic attraction. What's the meaning of electrostatic attraction? The opposite charge will attract to each other. The ionic bond, one of the strongest bond. It is the strongest bond compared to the covalent or the other bond or the physical bond. Very strong bond, okay? If we look here, after this electron goes from here, okay guys? This electron, we will cancel it, right? And he will go to the chlorine, and this is converted the sodium to a sodium cation with a positive charge in total. And this is convert the chlorine ion to negative charge in total. So the negative here and positive here attracted to each other to form the sodium chloride. Could we represent this by electron dot notation? Yes, we could. Electron dot notation. The sodium is in group 1, right? So how many dots are rounded? 1. Plus chlorine is in group what? 17. So how many dots are rounded? 7 dots. 1, 2, 3, 4, 5, 6. Sorry. So how many dots are rounded? 7. They will form a sodium chloride, right? So this electron here will jump from here to here. And this is what produce Na positive, because the sodium here lost the electron in the outer energy level to reach the octetrol. The chlorine here gained this electron, so plus Cl, but I have to write the number of dots now. So how many dots are around the chlorine atom, guys? 8. It's reaching the octetrol, right? 1 of the green dots of the sodium, and the other 7 of the chlorine. But this is the charge was negative charge. And the atom is actually neutralized because the number of gained electron is equal to the number of lost electron. Let's take another example, that the example in your book, and then talk about the characteristics of the ionic compound. Calcium fluoride, right? Another example, the second example in your book is calcium fluoride, right? Yeah, let's see calcium fluoride. I will save it, so don't worry. You could write in the end of the class. Yeah. Anyone have questions? Really? Sorry, what happened? There's no questions. So, very good. Now, we will go to the second example here, forming a type of ionic compound, calcium Ca fluoride, CaF2. What is this? The subscripted 2 here represent how many fluorine atom? 2 fluorine atom. How many calcium atom? 1. So we wanted to figure it with the same way. So let's draw the calcium atom here. This is the calcium. So the calcium in the group number 2, how many electron that it have? If you look to the periodic table, yeah, but what is the total number of atomic number of calcium? It's a 20. 20. So 20, if we represent this 20, the first one have 2 electron. The second one have 8 electron. The third one have 8. And the fourth one have, so 8 here for the calcium. And the last one have 2. 1 here and 1 here. The fluorine atom guys is in group what?
17.
So what is the atomic number of it? 9. So 9. The first one have 2. The second one have 7. 6. This is 3, 4, 5. And here is 7. Okay, guys? Clear? Okay. We will draw it with the equation here. And also we're represented by electron dot notation. The calcium is a metal that in group 2. So the calcium is capable to lose how many electrons to reach the octet rule?
2.
He will lose 2 electrons, right? You have 2 electrons in the outer energy level. So you could lose 2 electrons and convert it to Ca positive, how much? 2, with a charge of positive 2 cation plus 2 electrons. The fluorine atom is in group 17. He have only 7. So how many electrons one fluorine atom need to reach the octet? 1 electron. So the fluorine atom is capable to take only 1 electron to convert it to F negative. The first important rule that we said apart, the charge must be neutralized. This is mean the number of lost electron is equal to number of gained electron. So how we could solve this way? Yeah, so we just balance the number of fluorine atoms by multiplying by 2. So I will take 2 atoms of fluorine. Each atom will take 1 electron. So it's 2 electrons in total to form 2 ions. This is mean we will duplicate this part here. How we could duplicate it? We could not duplicate this atom. Okay. So I need another fluorine atom. Let's draw it. Another fluorine atom. 2 dots. Then how many dots, guys? 7. 1, 2, 3, 4, 5, 6, 7. Then this 2 electron here, 1 electron will goes to this atom to balance, and the other electron will goes to this atom to balance it. So this is the 2 electron of the calcium. Then this atoms here convert to what, guys? This has become an ion, right? And this is becomes anion negative. We will draw it right now. So and this one become positive 2 to neutralize this charge. Now we could represent it by electron dot notation. Electron so the calcium surrounded in group what? Have how many electrons in the outer energy? 2. So I represented by 2 dots. I have how many fluorine atoms now? 2 fluorine atoms. Each was one surrounded by how many? 7. This is 7, guys. Then we know that this electron will move here, this electron will move here to 4. Calcium ion, Ca positive 2, plus 2 fluorine atom, each one surrounded by how many dots? 8, because it's already gain. So 8 electron. Okay. Each atom take one of the electron that the calcium lost. Yeah, one here, one. But it's have a charge upon it. This is the charge is represented by negative. So the total reaction in the equation here, guys, after we balance it, so the 2 electron will cancel the 2 electron, and the total reaction calcium plus 2 fluorine atoms yield calcium fluoride as an ionic compound.
So here they are connected by sharing electron. Both fluorine atoms are sharing.
Not sharing, transferring electron. The electrons move from here to here. So convert. It's like the magnetism force. When you have 2 magnets, what they go when they attract to each other? They stick together. This is the same thing, but electrostatic comes from the opposite charges. So the opposite charges are in the cation and anion attract to each other to form the ionic compound. Understand how the ionic compound form? We could represent it in several ways. Now we get back to the slide to understand what is the crystal lattice, what are the properties of the ionic compound. So again, what is the 3 main idea we are gonna talk in those sections here, guys? First, we will explain the ionic compound and the ionic compound, how it's formed, the formation of the ionic compound. Okay, anyone have a question in that part? Okay, the second part, guys, is how to explain the characteristics of the ionic compound.